Welcome everyone. What's up everybody? This is Geometry. We're talking proofs. We're on page 363. This is going to get real, and this might be a long video because of it. So in order to be ready for today, for this video, as you're watching it, have some extra scratch paper. I'm going to intentionally use this, and I want to see evidence that you've done this when you do this page. It'll kind of slip into the book. Have multiple utensils to write with, right? Pens, pencils, all of it, right? And then also, because when we do the problem of this video, you're going to also be needing to use some of your geometry tools. So I've got a compass, now I've got a protractor here, so I can measure angles, and then I have my 3D printed compass that I'm going to be using along the way. All right, let's get into it. And again, stick with me. Oh, also, by the way, I'm going to let you know, you're going to need these vocab words. And so please make sure you have your Inscribed angle theorem card. Please make sure you have created one called the distributive property, which you've actually used. Maybe you used it back like in middle school or in an Algebra 1 course. With this, our favorite, our buddy, substitution property. Going to definitely use that one in this video. Definition of supplementary angles and intercepted arc. All right, we're going to use all of those or variations of those in our work today. Let's go. So here it is. Take a look. Let me move my camera down to the side. Kind of slide it on over. All right, in a previous topic, you made a conjecture that the opposite angles of cyclic quadrilaterals, aka inscribed quadrilaterals, are supplementary. That's a conjecture. We're going to prove that. That's the purpose of today's video. You can prove this conjecture using the Inscribed angle theorem, and so that's why this card is necessary. We're going to use this card to help make proofs. Remember, theorems, once they're proven, get to become cheat codes and shortcuts for us to use. So the Inscribed angle theorem is what we're going to do. Now look at this entire page. Oh my word. It says, create a proof of this conjecture. If you had nothing else to go on, we would have to say, all right, opposite angles of cyclic quadrilaterals. We got to understand what that is. Inscribed quadrilaterals. We got to understand what that is. Then it says they're supplementary, and we can prove it using inscribed angle theorem. What do we do? Fortunately, for you guys at this level and not at higher levels of mathematics, we're going to give you some structure. We're going to tell you the given statement. There's a quadrilateral. Its letters are Q, U, A, D, and it's inscribed in a circle. And then we're going to specifically prove that Q and A are going to be opposite angles from each other, but they're supplementary. And then U and D are the other pair of opposite angles in the quadrilateral, and they're also supplementary. So we got to know what supplementary means, right? Supplementary means that they add up to 180. We got to know what this even looks like. And as I look at the rest of the page, right, there's no picture. There's no like symbols, no other things that are provided. And so this is where I'm saying we have to have the extra scratch paper, because in these types of problems, you just have to create it for yourself. So we're going to literally create the circle inscribed in, or the quadrilateral inscribed in a circle, and then just build some like brainstorm things from there. Again, multiple parts to this. So let's do the first part. Let's actually see if it works. Okay, so to see if it works, I'm going to use my compass, and this is my technique. I printed this off, so I'm going to pin down the center by putting my pencil in that spot, and then I'm going to pick, I don't know, just somewhere out in the middle. I want to be able to manipulate the paper without too much issue. I want to get a circle on my paper and a little bit of finesse. There it is. That's good enough. Okay, now what I need to do is I need to actually mark 4 locations on the circle. And so here, let me kind of zoom in for a minute so you can see it a little clearer. Okay, I want to mark 4 spots on the paper because it's a quadrilateral, so I got to have 4 corners. Maybe I put a corner here, call that Q. And then I don't want to be too generic. I want to kind of like show a little bit of spice here. So I'm going to maybe try to be spicy by choosing some angled like locations. Like I don't That's an A, right? Q-U-A. We're spelling out the first four letters of quadrilateral. And I don't want to, my point is that I'm just trying to make sure that you understand I'm not really being intentional with where I'm picking these things. I'm just randomly picking 4 spots on the circle so that if I randomly picked another 4 spots on the circle, I'd get the same results. Supplementary. Okay, here. I am trying to use the blue lines. I'll tell you that. I'm trying to use the blue lines. I feel like the blue lines will help me be a little bit clearer with what I'm trying to do. And let's just explore it. We're supposed to create a 4-sided shape in the circle. So if I pick 4 corners and then I draw secant lines, trust me, that's what you need to do. Okay, secant lines. So I'm drawing a long secant line there. And I'm drawing a secant line here. And a secant line here. And then last of all, the 4th secant line. A secant line goes through the circle in 2 locations. So like all of these are considered secant lines because they go through the circle. And then if I just specifically highlight the chord right here, that chord, this chord, discord, I said it on purpose. And that one, you actually create the quadrilateral that we're talking about. So again, this is random. This is meant to be like a random arrangement of 4 letters. I could be very specific if I was trying to be, but I'm trying to convince you I'm not. So whatever quadrilateral you draw, which looks different than mine, will have the same results though, and these are the results. Let's get some angle measurements. Okay, so if you haven't done angle measurements in a while, remember your protractor, you put the circle on Q, and then you have to line up this line of the protractor with the secant line. So I'm going to swivel the protractor around until it's lined up. And I'm going to be very precise. I want to even include like 0.5 if I can. I want to be as accurate as possible. Okay, it's lined up, centered over, starting from 0 down here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It looks like 101. Right? Maybe a little bit more than 101, but not much more. So I'm not going to say 102. I'm going to call this a 101 degree angle. Now, if our proof, right? Bring the book back in. If our proof is true, angle Q and angle A will add to 180 because they should be supplementary. So I'm just going to guess right now that angle A is probably 79 degrees. 101 plus 79 makes 180. So I'm gonna measure. I'm gonna go right to angle A. Okay, again, the circle of the protractor has to go on the dot of angle A. And then the black line, the 0 angle line of the protractor has to line up with our secant line. And if we're off at all, it's because I'm human. Look at that. I made a perfectly 180 degree angle. I was not intending to do that. But if that's an 80 degree angle and that's a 101 degree angle, I'm human. I made a 1 degree mistake. 80 degrees plus 101 degrees is 181. So there's probably a little bit of fudging, and I'm going to fudge that this is where I made my mistake. That's really 79 degrees. Again, close enough for being human, not using a computer, but using actual paper and then this 3D printed compass that I made to draw my circle. We still get these 2 angles add up to 180 degrees, or are really close to adding up to 180 degrees. Let's just confirm that angle D and angle U also do the same. So here goes. Center of the protractor goes on angle D. The 0 degree line of the protractor has to line up with our secant line. And then starting from 0 degrees, 10, 20, 30, 40, 50, 60, 70, 80, 90, looks like 91, 92. Like it's about a 92 degree angle. So that's what I'm going to put here in the corner. 92 degrees. Now remember, if the conjecture is true, then angle U has to be the rest of 180 degrees. 180 minus 92, 88. Angle U should be an 88 degree angle. Okay, let's see what we get. Let's go centered. Line up the 0 degrees. And then Let's see here, 10, 20, 30, 40, 50, 60, 70, 80, 85, 86, 87. Again, I'm off by 1 degree, so I'm going to say that this must be just off by my human error, off by 1 degree. I got 87, so I'm going to round up to make it look good at 88. And it turns out, yeah, these two add up to 180. These two add up to 180. Let's actually say that over here on the side. 101 plus 79 degrees equals 180 degrees. And let's say 92 degrees plus 88 degrees equals 180. It works. It actually does work for my random example of a circle, an inscribed quadrilateral, and opposite angles add up to 180 degrees. And so that's what we're looking for in our proof. We have an example here that we can turn our attention to. Now there's going to be multiple parts for this page because there is a lot to do. So please click forward. Thank you for watching this video. Don't forget to like, comment, and subscribe. And let's be ready for our next video, part B of this page 363 video. See you in the next one.